Hi, this is Mrs. Doris. This is Lesson 9-2 entitled Quadratic Functions. Our objective is that you will be able to graph quadratic functions of the form ax squared plus bx plus c. And I apologize, I did not get my exponent up in the air. The reason that we are studying quadratic functions is because some real-life relationships can be modeled with quadratic equations. These are situations where the rate of change is not a constant rate. All right, so in the quadratic function y equals ax squared plus bx plus c, the value of b affects the position of the axis of symmetry. In our previous quadratic equations, we've not had that middle term, and so we found that our axis of symmetry was the y-axis itself, or x equals 0. But in these equations, we're now going to be moving that axis of symmetry someplace else. So the equation of the axis of symmetry is found by taking x equals negative b divided by 2a. The x-coordinate of the vertex is found using the same formula because the vertex is on the axis of symmetry. When you substitute 0 into the equation y equals ax squared plus bx plus c, you get 0. And down below we have shown that. If we put 0 in for x, a times 0 squared would be 0, b times 0 would be 0, and so we get y is equal to c. So in these cases, the y-intercept of a quadratic function is c. All right, so here are the steps to graphing. Our first step to graph a quadratic function in the form where we have all three terms, ax squared plus bx plus c, is to use the formula x equals negative b over 2a to find the axis of symmetry. And by doing this, we are also finding the x-coordinate of our vertex. Step 2 is to use that value to find the y-coordinate of the vertex. Step 3 is to find at least 2 points on one side of the axis of symmetry and reflect those points across the axis of symmetry. And step 4 is to connect the points from left to right with a smooth curve. All right, so problem 1. Graphing y equals ax squared plus bx plus c. Our question is, what is the graph of the function y equals negative x squared plus 4x minus 2? Well, let's begin by identifying our a, b, and c. In this equation, our a is that invisible negative 1 that comes in front of the x squared. Our b is the 4, which is the coefficient of the x term, and our c is negative 2. All right, so step 1 was to find the axis of symmetry, and we'll just abbreviate that using AOS. All right, so we're going to use our little formula, x equals the opposite of b over 2a, and substituting what we know for b, we have the opposite of 4 would be negative 4, and all over 2 times a, which is negative 1. So we end up with negative 4 over 2 times negative 1 is negative 2, or 2. All right, step 2 is we're going to find our vertex, and our vertex we know has an x-coordinate of 2. So we are looking for the y-coordinate. To do that, we're going to go back to our original equation and we're going to substitute 2 in. So I have the opposite of 2 squared plus 4 times 2 minus 2. All right, well 2 squared is 4. The opposite of 4 would be negative 4 plus 4 times 2 is 8 minus 2. Negative 4 plus 8 is 4 minus 2 is 2. So our vertex is at 2, 2. All right. Step 3 is we want to find at least a couple of points. So here's where I'm going to make an XY table. All right. And we can begin now to plot our graph. We know where the vertex is at 2, 2. We know from our coefficient of the x term that it's going to open downward. So I'm going to put my x-axis right about here, and I'm going to put my y-axis right here. Because we know that our parabola has a vertex at 2, 2. Which would be right here, and it opens downward. All right, so what we want to do is pick a couple points on either side. Now there's one that we know automatically, and that is looking at our equation, the minus 2 is going to be our y-intercept. So we know that at 0, negative 2, we're going to have a point. So 0, negative 2 would be right here. And we can do that just by looking at the equation. Let's select 1. 1 would be right in between, and that will help us. So we want to go to our equation, and I'm going to erase this just to make a little room, and let's evaluate what we would get if we put 1 in. We'd have the opposite of 1 squared plus 4 times 1 minus 2. Well, 1 squared is 1, and so the opposite of 1 is negative 1. Plus 4 would be 3, minus 2 would be 1. So at 1, 1, we also have a point. All right, at this point, let's go ahead and put our axis of symmetry down through the vertex and reflect these points across the axis of symmetry. And then our step 4 is to join the points with as smooth a curve as we can draw. All right, and there we have the graph of the function. All right, we have another vertical motion model in this lesson. If an object is projected into the air with an initial upward velocity v and continues with no additional force acting on it, the formula h, which stands for height, equals negative 16t squared, where t is your time in seconds, plus the velocity times time in seconds, plus c, and c is the initial height above ground. And this gives an approximate height above the ground. All right, so in problem 2, we're going to use the vertical motion model. And let me see if I can extend my screen. Let me move that up a little bit so we can get our graph. All right. All right, so here we go. Between innings at a baseball game, a t-shirt is launched by cheerleaders at an initial height of 5 feet with an initial upward velocity of 64 feet per second and is caught 35 feet above the playing field. All right, so what we're going to do is we're going to use our vertical motion model. All right, and then we're going to answer the questions on the next screen. Okay, so we have y equals negative 16t squared plus vt plus c. All right, let's fill in the blanks that we know. All right, we know that um, t is our time in seconds. We know that our initial velocity is 64 feet per second, and the initial height is 5 feet. All right? So what we're going to do, and I left out my t here. Let me put the t in. That's important. We're going to follow the same steps that we used for graphing a model. First thing we want to do is find the axis of symmetry, which is the x-coordinate of our graph. And we know that A is negative 16. We know that B is 64 and C is 5. So using our x equals negative b over 2a and substituting in our values, we have the opposite of b would be the opposite of 64, or negative 64, all over 2 times negative 16. Negative 16 is negative 32, and negative 64 divided by negative 32 is a positive 2. All right, so our vertex is going to have a 2 in it. Now, the next thing that we want to do is, I'm going to move this kind of up and out of the way, we want to find the y-coordinate of our vertex. So we're going to go back and we're going to put 2 in for the number of seconds. All right, so I'm going to write it up here. I don't have a lot of room here. We've got y equals negative 16 times 2 squared plus 64 times 2 plus 5. All right, so 2 squared is 4 times negative 16 would be negative 64. 64 times 2 is 128, and then plus 5. All right, well, negative 64 plus 128 is 64, and 64 plus 5 would be 69. All right, so let's talk about what this all means. Our vertex is 269. That is the maximum point or the vertex on our graph. So let's see. On our graph, we're going to put our height on the y-axis, which will be in feet. And let's see, can I go, let's see, 10, 20, 30, 40, 50, 60, 70. All right, so I'm going to go by tens on my graph. Make sure that you evenly space those. And then across the bottom, we're going to have our time in seconds. All right, and so I'm going to put 1 here, 2 here. All right, so we know our initial height is 5. Let me put this in red. There's where they shoot the t-shirt from. All right, we know that at 2 seconds, it is at 69 feet, which would be up here. All right, and then what we want to do, or we know that it is caught at 35 feet above the playing field. So what we know from this is that our y is 35. All right, at this point we're going to draw the initial part of our parabola, and then let's go on to the next, the questions that we have to answer. All right, so the question is, how long will it take the t-shirt to reach its maximum height? And we have found the answer to this when we found the axis of symmetry. It only takes 2 seconds for it to reach its maximum height. That's the x-coordinate of the vertex. How far above the playing field will it be? That's the 69. When we substituted in 2 for the number of seconds and found out how high it would go. And our last question, what is the range of the function that models the height of the t-shirt over time? All right, well the height, if you remember, it started at 5 feet. And it was caught at 35 feet. All right, so 35, our maximum height was 69. So our height is going to be 5 is less than or equal to the height, which is less than or equal to 69. All right, if you have any questions, please don't hesitate to ask. You may go ahead and begin the lesson check on 9-2, and I'll be happy to answer any questions that you have. Thank you.